At the beginning of this chapter, again, we saw how we could easily convert from decimals to fractions. If I were to say 2.7, we knew that that meant 2 and 7/10. That was the literal reading of that number. But you could also write this as the improper fraction 27 over 10. And the easy way of doing that was to take the number that you saw here, like if I were to take 4.13, if you take that without the decimal, say 413, and you divide it by the power of 10 that matches the number of decimal places with the number of zeros, so that would be over 100. 413 hundredths. Okay. Although we say this as 4 and 13 hundredths, you have 2 decimal places here, you have 2 zeros here. That was the connection that we made going from decimals to fractions. Now, if I want to go from a fraction to a decimal, all we have to do is division. So this is going from a normal decimal to a fraction. But if I were to take something like this, 3/4, how do I go from this guy to a decimal? There's a really easy way. Just what? Divide. Just divide. So you would divide 4 into 3. Please make sure that the divisor, what you're dividing by, always goes outside of the long division symbol. Now, where is the decimal for the 3? It's immediately behind it, so make sure you understand that and go ahead and move that up. And I'll go ahead and let you know there are going to be a couple of zeros here that we have to add on, because 4 doesn't go into 3. 4 goes into 30 how many times? 7, because if you say 6, 6 times 4 is 24, the remainder is larger than the divisor. So 7 times 4 is 28. And then you have 2. When you bring down this 0, 4 goes into 20 5 times. And so this is us going from a fraction to a decimal. Now, I trust that you can do the long division. This is not where I want to spend, this is not where I want to focus. I want to focus on things that we should memorize. Yes, there are things that you should know how to do through repetition. There are procedures to follow, and you do them over and over, and you don't really have to think about it. Just like you don't really think that much about driving and how to brake and how to accelerate. It becomes natural to you. Instead of going left, brake, right, go. If you still have the Post-it notes on there, like maybe you have a little Post-it note that's on the dashboard that has, you know, arrow pointing to the left that says left, arrow pointing to the right that says right. That way you know which way to go. But there are some things that we do memorize, like your multiplication tables, and some very special fractions that we should know the decimal equivalent. So one of the easiest ones to know is 1/2. What is 1/2 as a decimal? Come on, we just got done making fun of Ghirardelli chocolates. 0.5, right? This is one of those guys that you should know. You should know this guy along with some of the other nice ones, like, what? Are you asking about the 0? I do that to emphasize the decimal point. You could just say 0.5, but I like putting the 0 there. That way the decimal doesn't get lost. And I know you guys have never had symbols get lost, like a negative. You never lose that. So, what about 1/4? That's 0.25. We know this guy, right? And another, if you know 1/4 and you know 3/4, and we just said that guy's 0.75, right? Those are some of the easy ones for us to know. If I have 1/3, now what's 1/3? This is the one that's 0.3 repeating. It just keeps on going. Know this guy. Much the same way that you should know that 2/3 is, well, look at this. 1/3 compared to 2/3. That means 2/3 is twice 1/3, right? So what do you think twice or double 0.3 repeating is? 0.6 repeating. Know this. Memorize it. And I'll quiz you on it.
Oh, snap!
Yeah, that's right. That's what I had done just said. Some other good ones here. 1/5. Of course, for all my specs customers, you know what 1/5 is, right? When you see a fifth, that means a fifth of a liter, which is 200 milliliters, right? Which is 0.2. Of course, that means that 2/5 would be what? 0.0 or 0.4, which then means 3/5 would be what? Wouldn't it be 0.6? And here's a little fun side note for you if you're trying to figure this out. How does he get that? How does he know this stuff? Well, let me show you. If I looked at 1/5, now we know that we can make equivalent fractions, right? We did that in the last chapter. If I were to multiply this guy times 2/2, right? Can I multiply times 2/2? Because that's really multiplying times what? 1. That would give you what fraction if you do that? Wouldn't that give you 2/10, which would literally be written as 2/10? Huh? Same thing you could do here or here. If I multiply this guy times 2/2, well, that would give me 6/10, which is that exact guy right there. Now, let me tell you something. If what you're dividing by is made up strictly of factors of 2s and 5s, your decimal will come to an end. So if I'm dividing by, say, 5 or even 4, what is 4 made up of? What are its factors? 2 times 2. If your only factors of your denominator are 2s and 5s, you will have a decimal that ends. If it's anything else, the decimal will keep on going. Now, if I'm doing fifths, I might as well go ahead and do tenths, right? Because 1/10 is just what? Wouldn't that be 0.1? Right? And of course, if we did 1/100th, that would be what? Wouldn't that literally be 1/100th like this? This is important stuff for us to know because later on we're going to be talking about percents. Percent means per 100. So 1 per 100, 1% means 0.01. Right? And we use these in everyday life. If you look, and we will do this, if you look at nutrition labels on the food that you consume, there are percents on there. There are decimals. There are all kinds of numbers. And if you understand what those are, it can make you a better consumer, and it can also make you a healthier consumer if you know what you're taking in. Now, I know that there are all kinds of things that are changing in terms of nutrition labels. Like if you look on a can of Coke, and I don't mean like those mini cans of Coke that are like little shots. They're just nothing. Like a regular 12-ounce can of Coke is how many servings? It's supposed to be 1.5 because one serving of a soda is 8 ounces. 12 ounces is 1.5. Now, I think on a can of Coke it may actually say like the whole serving, or the whole can is a serving. But if you were to look at, say, a 16 ounce or a liter drink that you guys may buy, it has per serving. And if you look at a liter, that's a little over 4 servings. But they don't put the total amount on there. So you got to be careful. Here's some other good ones to note. 1/6 is 0.16 repeating. Now notice that the repeating bar is only on the 6, not the 1. So what is the pattern here? It goes 0.16, and then the 6's are what repeats. Here are two of my favorites. These just are so neat. 1/9 is 0.1 repeating. 2/9 is 0.2 repeating. Now you don't need to worry about 3/9, although you could. 3/9 would be what? 0.3 repeating, but you already know 3/9 would reduce to what? 1/3, which is 0.3 repeating. Now these are some of those I always like to work with. 1/11. 1/11 is 0.09 repeating. Now notice that the 0.9 has the bar over it, so that means it's going to go 0.09 what? 0.9090909. So if I have 2/11, wouldn't that double this and make it what? Isn't that 18 now? So that'd be the 18 that repeats, so it'd be 0.181818. So what do you think 3/11 would be? Do you see the pattern yet? It'd be the 27 that repeats. All right, well, let me jump ahead. What if I have 7/11? That would be 0. What? What's the pattern here?
63.
It's going to be 63 that repeats. So what's the pattern? If you're dividing by 11, how do you quickly go to the decimal? You multiply it times 9. 1 times 9 is 0.9. You have to have the 0 there. 2 times 9 is 18. The 18 repeats. 3 times 9 is 27. 7 times 9 is 63. Just like here, if you're dividing by 9, if you multiply times 11, 1 times 11 is 11. 2 times 11 is 22. But if you have 22, 22, 22, it's really just 2's that are repeating. So it makes it really nice. Know these and memorize them.